Okay, so we want to review our lesson on electromagnetic radiation. And we're really going to focus here on visible light part of the spectrum. So we're going to look at Roy G. Biv. So we know that that represents um, R is the red, O is the orange, Y is the yellow, G is green, B is blue, I is indigo, and V is violet. And we want to talk about the relationships that we should know from electromagnetic radiation. So here I have my fluorescent material, and we're going to look at three different photons of light. So the first one we're going to look at is red light, okay, which is at one end of our visible light spectrum. And so I'm going to take my red light and I'm going to shine it along my fluorescent material, and we notice that nothing really happens. So here's what we know about red light, and you might want to pull out your electromagnetic radiation lesson, and that way you can double check your answers. So here's what we know about red light. Red light has a long wavelength, and we know that wavelength and frequency have an inverse relationship. So if there's a long wavelength, then we know that it has a low frequency, and frequency and energy are directly related. So if there's a low frequency, there's a low energy. All right, so that's our first photon of light. Let's look at the next one. So let's look at kind of like the middle of the spectrum of visible light. Let's talk about green. So again, here's my green photon of light. Okay. I'm going to shine it along my fluorescent material. And you might notice a little bit of an afterglow as we're kind of moving along here. Okay. So that tells us, since we're getting a little bit of an afterglow here, it has to have more energy than what we saw with the red. So let's talk about green. Okay. All right. So green light is going to have a little bit of a shorter wavelength. Okay. Than what we saw with red. So it'll be, and so that means it'll have a higher frequency than what we saw with red and a higher energy than we saw with red. All right, and then we're going to look at one more along the visible light spectrum. We're going to go to the other end of the spectrum and we're going to look at violet. Okay, so I'm going to put my fluorescent material back up here. And again, we're going to use violet photon. So here's my violet light. Okay, and then you can clearly see that as I move this along, that glow along my fluorescent material. Okay. So this tells us this has to have more energy. So violet light has a really short wavelength. And wavelength and frequency are inversely related. So if I have a short wavelength, this is going to have a high frequency, and frequency and energy are directly related. So this would have a high energy also. And that's why it allows my material to fluoresce.